In this section, we're going to look at multidimensional arrays. So far, we've been using one-dimensional arrays to model linear collections of elements, but we can also use two-dimensional arrays. Two-dimensional arrays are used to represent a matrix or tabular data, data that's stored in a table. Probably the most familiar thing that most of us have used that might be similar to that is like an Excel spreadsheet. It holds tabular data. It holds rows and columns of data. A two-dimensional array is like an Excel spreadsheet. So here's an example of a table that describes the distances between cities, represented using a two-dimensional array. So we have the cities on both sides: Chicago, Boston, New York, Chicago, Boston, New York, and the numbers in the table hold the distances between those two cities. So Chicago to Chicago, obviously, 0 miles. Chicago to Boston is 983. New York to Dallas is 1,548. So this data is stored in a series of rows and columns. Okay, and that's what we use a two-dimensional array for, storing items in rows and columns. So let's take a look at this data, the numbers that are stored in this table as code. So we have a two-dimensional array called distances. Okay, it is an array of doubles, and the two sets of square brackets show us that it's a two-dimensional array. And here is the data. It's the same data we saw back in this chart. 0, 983, 787 going across. And you cannot see the other data going down. So let's talk about how to decode the numbers, the index numbers in an array. Probably the easiest way I have found for people to think about this is that a multidimensional array is an array of arrays, an array that contains other arrays. So you can think of each of these rows as an array. This is array 0 in this row. This is array 1 in this row. This is array 2 in this row. Okay. Each array has its own number of elements. In this case, array number 2 has a 0 as its first index and a 0 in its second index, which is index 1. And a 0 in index 2. It has zeros everywhere, as a matter of fact. So when we read the indexes in an array, we read the row number first. Okay, which array am I looking at, or which row in my rows of arrays am I looking at, followed by which column am I looking at. So it's row, then column. I find students of mathematics who are used to using ordered pairs are the first people that have problems switching. Because in normal mathematics, when we're doing graphing, the first number is usually the x-axis going right to left, right? Which would be more like a column, picking the column, and then the second number is the y-axis up and down, right? And it's kind of reversed here when we're talking about arrays. The first number tells us which row we're looking at. The second number tells us which column within that row. So if I said 3, 2, matrix 3, 2, I would come down to index number 3 and across to index number 2 in that particular array, and I would read that value right there. Okay. Here's another example, matrix 2, 1. Okay, so we're looking at row 2, item number 1, and there is a 7 in there. And we can assign, and that's what this statement is actually doing. It's assigning 7 to row 2 and column 1. Over here is a smaller two-dimensional array. It has 4 rows and 3 columns, which is perfectly fine. They don't have to have an equal number of rows and columns, even though our examples so far have had it that way. So here is row 1, the first row, index 0 is a better way to say it. 1, 2, 3. Row index number 1, that's a 4, 5, 6. Array number with index 2 has 7, 8, 9, etc. We're going to talk about length in an upcoming slide. Let's first talk about how we declare a two-dimensional array. Okay, to declare a two-dimensional array, it's just like declaring a single-dimensional array. So if I have this array called ref var, or reference variables, it holds some kind of reference variables, maybe. I give it a data type, and I give it a set of square brackets for each dimension. Okay, so this would be rows, this would be columns. Okay, so that's how I declare it. And then I have to create, so I've got this declared variable ref var, and then I have to actually create an array. So I create a new, I name my data type, and I tell how big I want the array to be. Okay, in this case, it's going to be 10 rows with 10 columns in each row. Okay, so I've declared this to be a 10 by 10 two-dimensional array of whatever data type I substitute in here. Okay. And of course, we don't have to do that in separate lines, and rarely do we ever do it in separate lines. Usually we do something just like this. We say new, name our data type, give the sizes for the rows and columns of our array, and assign it to the variable and declare the variable at the same time. We do it all in one statement. So declare the variable on the left side as a two-dimensional array. On the right side, create the actual array object in memory with the proper data type and give it the sizes. And again, the book includes the alternative syntax using the square brackets after the variable name instead of with the data type. Just let's pretend we don't see that. Although Java does allow it, let's not do it that way. It's just not, most people don't do it that way. It'll save you confusion in the future. All right, so how about the lengths of an array? How do we talk about the length of an array? So in this case, it's an array of arrays. So when we talk about length, are we talking about the array that holds the other arrays, or are we talking about the individual arrays in each row? We don't know. What's the difference? How do we tell? So we have an array here called X. Okay, we created an array called X. It has 3 rows and 4 columns. Okay, if I say x.length, if I just say x.length, that tells me how many rows it has. So this one has 3 rows numbered 0, 1, and 2. So when I say x.length, that tells me the number of rows. To find out the number of items in each row, I have to tell it which row. So if I say x sub 0.length, it tells me 4. Okay, if I say x sub 1.length, I get 4. X sub 2.length, I get 4. Now you may say, well, it always has the same number of columns in every row. Why would we be able to do it with any of the rows? Because we don't necessarily have to have the same number of columns in each row. There's something called a jagged array, which we'll talk about in a little bit. Okay. So generally, they are rectangular shape with the same number of columns in every row, but not always. Here's a two-dimensional array. This is the shorthand way to declare a two-dimensional array. Let's take a look at this. So I have an array called array with a small a on it. So array is my variable name. It has it's a two-dimensional array, so it has rows and columns, and then we're actually specifying the values that are going to be held in the array as we declare it. So the first row is 1, 2, 3. The second row holds 4, 5, 6. The third row holds 7, 8, 9. So this is row 0, row 1, row 2, and row 3 if we're looking at index numbers. Okay. Notice that these curly braces specify an array. So this is an array, 1, 2, 3. This is an array, 4, 5, 6. This is an array, 7, 8, 9. These two curly braces show that these arrays are held inside another array. That's why I say sometimes you want to think of it as an array of arrays. Rows and columns are probably the way that people most like to think about a two-dimensional array. Okay, so if I say array.length, Okay, that tells me how many rows. So the answer to array.length, if I say array.length, it would be 1, 2, 3, 4 rows. So array.length is 4. Array 0.length says how long is the array with index 0, and it is 3 long. So is this row. It is also 3. This row is also 3, and that row is also 3. Okay. If I try to get the length for array sub 4, there is no index 4. 0, 1, 2, 3. There is no index 4. So I would get an array index out of bounds exception thrown. So you have to be careful that you don't try to access an element that doesn't exist. All right, declaring variables of two-dimensional arrays and creating a two-dimensional array. So up here, we are creating an array of ints, a new array of ints that is 10 rows by 10 columns. Okay, we're assigning it to this variable called matrix, which was declared to be a two-dimensional matrix of ints. So we could assign matrix 0, 0 equal 3. That would assign the first element, and we'd have to go through 10 by 10. That would be 100 statements. Because this is 10 rows by 10 columns, we'd have to do 100 of these statements. Here is a for loop. So we're going to use, anytime we use multi-dimensional arrays, we're going to use nested for loops to process them. So let's take a look at how this works. So I have a for loop, and inside that for loop, I have another for loop. And inside that for loop, we're doing some things. As a matter of fact, we're setting each element, we're math.random times 1,000. So it's going to be from 0 to 999. We're rounding it off to an int by casting there and storing it in each row and column. The inside for loop, which is j, is counting the column. Remember, the second number is the column. The outside for loop is counting with I, which tells us which row. So this outside for loop will start at 0. Then the inside for loop will run 0 through 9, which is 10 columns. Okay, because its length will be 10. So it'll count for j while it's less than 10, which is 0 through 9. Okay, so it'll process 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. It'll count j up. Okay, once it gets to 9, this inside for loop is done. It goes back to the outside for loop. I becomes 1. And then we start 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. And it continues to count, processing using both loops and setting each element in this array to a random number from 0 to 999. Okay, so two-dimensional arrays are often processed with nested for loops. Better variables to use here than I and j that might make it more clear for you is instead of I, we could use row. And instead of j, we could use column. Okay, that a lot of time clears up a lot of confusion for people with the i's and j's. It takes a little while to get used to using the single letter variables. Or if I used row and column, it's easy to see. This is the row, this is the column. Which row, which column? Which row, which column? Okay. Down here, they're declaring a two-dimensional array of doubles and calling it X. That's a terrible name for an array, but they're using it in the book. Use something more descriptive than single letter variables. So, shorthand notations, we can declare an array and initialize it at the same time. We already saw an example of that. This saves us a lot of work. This is a 4-row times 3-column array that counts from 1 to 12. If we wanted to do this manually instead of using the shorthand notation, we would have to do this. And remember, each of these statements, it's a semicolon after it, 12 different statements. This is a single statement. Okay, so we declare the array here and we initialize each element individually. This one implicitly sizes the array and sets each element implicitly as it goes. And then here's the example of ragged arrays. This is a two-dimensional array. The rows can have different lengths. We looked at a lot of examples, and typically everything has the same length, but not always. So here's declaring an array. It's a two-dimensional array called matrix. Okay. And we have the opening curly brace and the end curly brace because it's an array it contains more arrays. And each of the arrays inside this outer array can have different lengths. There's nothing wrong with that. This one has a length of 5. This one has a length of 4, 3, 2, and 1. Okay. We can still access each item. So if I wanted to get item matrix sub 3, 2, 0, 1, 2, 3, 2, that would be that 5 right there. So that would be 3, 2. What if I accidentally said 3, 3? This row, 0, 1. There is no 2 there. I made a mistake. I can't access 2 out of that row. So you have to be careful with these, that your index, that you don't actually access an index that doesn't exist. So this one goes 0 through 4, but this row only goes 0 through 3, 0 through 2, 0 through 1, and just item 0 in that row. However, let's go back and look at the nested for loops. Okay, so these nested for loops will still work to process a jagged array, because I want you to look at what we're counting to. We're counting from 0 in both cases for row and column. We're starting at 0, but each one of them is counting up to, the outside loop is counting to the length of the matrix, which was the variable name we used here. Okay, matrix.length. And the inside loop that processes each of the items in the rows is counting up to matrix sub I. So if we're on row 3, index 3, it's going to get the length of the row with index of 3, and it's only going to process that many entries. So by not hard coding values in here, each row can have an actually different length, as in this example. Okay. Some people will call these jagged arrays instead of ragged arrays, so you look out for that nomenclature as well. This is a triangle array. Similar thing, except this time it's going, actually it's the exact same thing, just showing it a different, a little bit more precise layout. All right. So in the next videos, I'm going to pull up some different examples. We're going to look at some different ways to process arrays and initialize arrays and use them for various different things.